Okay, so this is exam 2 review session. Of course, I posted the practice material some time back. That's like more than a week now, and also the solutions. So most of you must have like gone over those. And so the plan for today is to again like go over some of the logistics side of things, and also then go over the topics that I feel are important from the perspective of like today's exams, and then like also look at the questions that I feel can be helpful for today's test, right? So that's the plan. And like as we go over any topic, or if you feel that there is something that you would want me to explain again, or like go over that, we can do that, right? So please keep entering your questions in the chat window. And if you feel there is something that you haven't understood as well, just let me know and then we can go over that. All right, so having said that, just to reiterate, although I know everybody knows that we have test 2 tonight, that's April 1st, and this will be a 90 minutes exam. The format is exactly the same as exam 1. So I think now there is no anxiety related to like what the format would be, how to like access the exam, how to submit. And why I'm like repeating that is because like during exam 1, I received like so many emails with people asking me how to access the exam. So now you know that there will be an exam 2 gradable that you just have to go and access. The moment you um, push the accept button, your timer begins, right? So there is no timer that you can see on your screen. So you have to keep a watch or something to time yourself. It has to be done within 90 minutes. You shouldn't go over 90 minutes. And if you go over 90 minutes, then there is like a deduction of 1 point per minute. All right. Then, of course, like we have accommodation students already set up. If you're an accommodation student, you have provided us a letter and still you see that you're like after the 90 minutes mark, you're losing points. Do not worry, just like drop in an email and we'll adjust that. So that's not something like that is to like panic about, because I've added like all the students who have provided us with the accommodation letter based on like whatever time they have. But just in case something goes wrong, don't worry. I can adjust it later on. All right. So again, going back to the format of the exam, it's like 2 to 3 problems. To be exact, 3 problems, just like the previous exam. And what you'll do is write and submit code for each individual problem on submittee, just like exam 1 again, not auto-graded. So you'll not see how much you scored because we want to manually grade. We don't want to penalize people for minor syntax errors or formatting type things. So that's why we manually grade them. And one thing for this exam, which wasn't like as relevant in exam 1, is that we usually recommend people not to use IDEs. So that means like not use Spider, and instead just like try to focus more on the solution than getting like small syntax errors right. But if you're not comfortable like writing it on a notepad or writing it on some like text editor, I'm fine if you're using Spider, if you're more comfortable there. The whole point here, like what I'm trying to say here, is that do not get overwhelmed if you're getting a minor syntax or printing issue. If it's a minor printing issue, most likely you'll lose 1 point. So don't spend like a lot of time simply trying to get the printing right in this exam. Of course, the printing part was important in exam 1 when we were working with strings and print and other things. But with this exam and like the final is as well, it's more to do with the solution part. So if you have the algorithm and if you have the solution almost correct, and maybe you are making some printing mistakes, most likely you're losing 1 point out of like 40 or 30. So that's not something that should like make you sit there and get uh, overwhelmed. So that's the whole point here. Of course, this is that's fine. Yeah, this another point, like please try not to send emails during the exam time. If you're doubtful or confused about a problem, just write a comment saying that this is how I interpreted this problem and that's why this is the solution. And I have like in like the past exams in previous semesters accepted different variations of the problem provided the student provided and like in a comment about the interpretation, like maybe you can perceive a problem something different from what I am perceiving, right? So we have taken them as like correct solutions before. So that's not something unusual. So if you find something that's like doubtful or confusing, just write down that I found this confusing. I found like the meaning of this is this, right? And then just like go ahead and write the solution. You don't have to like email me telling me all this, right? The other thing is like in case of an extremely urgent situation, like I don't know if the internet is down forever or like you lost electricity or something, maybe you can email me or maybe like try to finish your code and submit it like even if it's like overtime and then email me. That would be a better like strategy because I can go and adjust like the points that you lost on whatever, right? Because of some unavoidable issue. But then it's better not to like email me directly, but rather on this like CS1 instructors list because there are more than one people that are monitoring this, so you can get a reply faster. All right, coming to the exam itself, it's an open book, open notes, open reference material exam. That means whatever we have provided, whatever material we have provided in this course, including the lecture notes, the homeworks and everything, you can refer to that, right? But please don't like try to contact each other for help. And that's important because believe it or not, in the previous semester, so many students lost so many points. I mean, just because like they didn't submit their own code and they were like collaborating during the exam because we do run MOS on your submissions. And if like there is a match that's close enough, then what we do is like the penalty is like 0 on the exam and minus 10 on your overall grade for the exam. So my recommendation is if you've scored like, let's say 70 or like 60, right? At least you're getting those 60 points instead of like collaborating with somebody, got 100, but then of course, like your match was found and then you lost all of that, right? So make sure that you're submitting your own work. And so those were the logistic instructions. Let me see some questions I saw coming up, but Peter, I'm not sure whether that's a question or a comment. Caesar, because of the time constraint, do we need to comment our code? No, no. So those things like about program structure, we are like really particular about those for the homeworks because you're getting 1 week to do that, right? So because of time constraint, there is no need to comment. Just like write your solution. Rochelle, you're saying what app would you recommend instead, or would we just write on a notepad and submit that? All right, so my recommendation is like using some text editor like Sublime Text, if that's like something that makes you feel comfortable. But I'm fine if you want to write it on Spider. That's not something that I'm not recommending. Just that if you're getting a minor syntax error, you know that your entire solution is working fine, and maybe some printing errors. Don't spend too much time on that. That's it. Otherwise, please go ahead and use Spider as well. Okay, that's fine. Yeah, Rochelle. So that's what I'm saying. Like instead of Spider, you can try Sublime if that's something that because that's a nice text editor. But if not, like use Spider, that's fine. Just that like sometimes what we do is we get stuck with like the execution of the code. Although you're there, like you have the entire solution, but you're just like spending too much time in there. All right. So Caesar, you're saying, do we need to use the guard, like if name equals main? Again, it's optional. We are not taking off points for the guard on the exam. And I don't think like any of the questions is that long, or maybe it is. I don't even remember now. Yeah, I mean, I'm not taking off points on like not using the guard or not using good variable names. It's like it's a good practice to use reasonable variable names, but not that we'll take off points on the exam for that because we understand that like you have this timed uh, like set up right. So all right, so this is the overview document. The overview also talks about like what material is covered. So of course, uh, you should be able to use whatever we learned before lecture 7 as well, like strings and I don't remember what all we learned before that, because that will be useful to solve problems in this exam as well, right? However, like the focus will be from 7 to 16, and if I go back and check what is 7 to 16 here. So 7 begins with tuples, modules, and images. And so here I would say focusing more on tuples and modules because images are not there on the exam, so you can skip that part. And the other thing is then, excuse me, after like tuples and modules, uh, we had lists which weren't allowed, if I remember correctly, on exam one, and loops were also not allowed on exam one. So the focus of this exam is lists and loops. If like maybe I'm like giving out too much, but lists, loops, and controlling loops, basically all about loops and lists is what I'm focusing on this exam, because you weren't tested on that on exam one. Right. So that's their data from files, yes. So I mean, in terms of data from files, I would say focusing on be prepared to open a file, read the contents, and do something with it. So remember, whenever we are reading in a file and then we are converting it to maybe a list, that's the most like creating parsers, right? Writing a parser, that's something that you should be very well familiar with, and we've done a lot of like problems based on that. So that's something that I would say focus on. And so we cover sets and dictionaries part one, not part two. So what does that mean? Well, that means like in dictionaries part one, although like I remember the lecture exercise asked you to go into the loops, right? The loop part of dictionaries. But mostly we'll focus on like how to create dictionaries, how to access values in a dictionary, and then, yeah, mostly like how to use values in a dictionary. So this would be a good, nice example to kind of demonstrate that here. So here I'm creating a dictionary with a set value, and then I know how to access it. Or for example, here I'm creating a dictionary with like tuples as values, and then be familiar with how to use the values, right? So those are some of the important topics. I don't think we are testing you on looping over dictionaries, although I don't think there is anything like new about it. You already are familiar with loops, but just like to give you an idea, be prepared to know how to create a dictionary and how to access elements. So that's the focus. Okay, so here I think I like described what other things that you should be focusing on. Um, of course, like these things like truth tables, Boolean expressions, logical expressions, they will be useful in solving those problems that are there. But like explicitly speaking, I would say focus on list of lists, reading in files. Those are like really, really important concepts. Okay, let me see. Yeah, I think I already talked about this point. We can like things from like previous lectures can also appear, but that's more like uh, all right, that's a wrong date. I already, anyways, I already released the solution, so that's doesn't really matter. Okay, so I have posted like the second exam from fall 2020, and we will go over that as well, because that's like something very similar to the actual exam. So that's something that you should focus on. Here, I just wanted to go over a few problems that I feel are relevant from the perspective of like today's exam. So only those problems I'll go over. And if you have questions, we can just like, you can ask and I can answer those. All right, I saw some questions. Lenny's, when opening a file, do we have to do the encoding? Well, I mean, it's a good practice to have the encoding parameter there, but if you don't have, I don't think we are using any files with like special characters. So even if you don't have it, I think it will work. Hemming, your question is, are you going to post a PDF this time? It's very hard. Oh, okay. That's a good point. And let me note it down. I can post a PDF as well. I can do that. But I'm thinking how to like inform everyone about it. How many people are there in class? Maybe I can make an announcement on, okay, we have 81, but I know like we have around 200 students. So what I'll do is I'll make an announcement on Submiti telling everybody that the PDF is also posted with the same questions on Submiti under exam 2 folder. So maybe I can do that. And if that is easier for you, just like get the PDF and work with it. Yeah, that's a good point actually. So I'll do that as well. Like in addition to the problems there, I'll post the PDF also. TN, you're saying, can we have the text file used in exam for testing code? Usually we don't provide that in the exam because we just give you like a snippet of like, this is what the file looks like. But yes, I can provide if that makes it better. So let me do that as well. I'm just like making a note before I forget. So just give me a second. Okay, I'll do that. I'll post, if there is a txt file, I'll post that, and I'll also post the PDF. Okay, so moving on. As I said, let's go over the problems that I feel are important from the perspective of today's exam. So this one here, consider a simplified version of the lab Yelp data. So we have looked at Yelp data, and the problem is asking us to go over this list of lists, right? And the input is not a file here, but it's a list of lists. So like focus on what is the input. It's not my Yelp file. If it was the Yelp file, then I would have to go and open it, but I don't have to do that here, but that's fine. The important point that I wanted to point out here is like how to get these elements in a list of list and work with it. For example, here it's asking us to write a segment of Python code that prints all Italian restaurants in the restaurant that have no ratings of value 1 and at least one rating of value 5. So you know that this is like an expression, a logical expression that is testing for like 3 values. So first thing, know how to go over like a list of lists. So for example, let me quickly show you what I mean. Maybe I'll write it here only, right? So like be familiar. What I'm trying to say is like when you're looping through, let's say this, like, so I'm saying for I in restaurants, right? This I is essentially picking up my sublist, right? So then if I want to like do something with these elements here, I should know the indices. So for example, of course, I have to go and check if the restaurant is Italian or not, or whether the rating is 1 or 5, or whether they are there or not, right? So maybe having like maybe 3 if statements or like a single if statement is fine. So for example, here for I, if I, and then what is the position of the restaurant type? It's like position 1, right? So if I, excellent, yeah, everybody is right. So I'll say I1 and then go and check if that I1 is Italian or not, right? And of course, the type is important. So the type is string, so I'm keeping it string, right? And then if it is Italian, then go and check for the rating, right? And here slicing would be really useful because I have to go and check the lists that have no rating of value 1. So maybe I can say if 1 not in something, right? So if 1 not in, and why I'm talking about like slicing here, that's because I have like these elements that are starting from position 0, 1, 2, right? So I can simply go ahead and slice this. And so I can say I starting from 2, go up to the end and check whether it's there or not and have another if statement, or maybe like have all these 3 in a single line. That's totally up to us, like have an and, because this is what exactly this like if nested if does. It's an and essentially, and implementation of and. So the things that I wanted to focus here on here in this like problem are like how to access sublists and how to access elements of my sublist. And sometimes like a very, I would say, common question could be go and calculate the average of this, right? If you have to calculate the average of like some elements in a sublist, know the indices, because mostly we are dealing with either regular tabular data or irregular tabular data, right? So the good thing about these 2 data types are that like there are these indices that are common to every line. So I can utilize that, right? Which is the case in this particular problem. All right, any questions regarding like list of lists in general, or like anything related to this or in general about list of lists? I think I saw a question. They just, yeah, Caesar, you're right. So that's correct. Harun, your question is, what is the difference for I in restaurants and for I in range alien of restaurant? That's a good question. And that's why I wanted to pick up this problem, because I have seen that confusion a lot. Okay, so let me show you what I'm saying. So the general structure of like a for loop is for some variable in restaurant. So when I'm saying this, that means whatever elements are there in my restaurants, go and pick them. So I'll go and check whatever elements are there in my restaurant. So these elements themselves are sublists, right? These are sublists. So that's what my eye is going to pick up. Let's say my restaurant was something like this. Let's say restaurants looked something like this, equal to 1, 2, 3, 4, right? So there are no sublists here. If I run this exact same loop for this one, right, for I in restaurant, then I will have these values like 1, 2, 3, 4, and so on, right? So that is what I in restaurant does. The other variant of like for I in range len restaurant, and let's assume that's an entire restaurant because there is no space. So here I'm saying I should take for variable in some iterable, and my iterable is the range function. And remember what range function does? It just like creates this set of numbers, or I would say sequence of numbers. That's it. So that means this I has these numbers in it, right? So I will take values because it's saying range length of this, and range stops one before the length, right? So I will have values 0, 1, 2, up to this 1 less than the length of the restaurant. So obviously in this case, I'll have to figure out how to use these indices, right? And so if I'm using this variant here, then I know that this 0, this position, has to be utilized based on whatever elements I have. So for example, the elements in my restaurant list are sublists themselves, right? So if you're using this, like for I in range len, and somewhere in the loop you're saying restaurant, and then this restaurant I is going to pick up like this entire sublist. So if you want something inside it, you'll have to like go and do another square bracket and say 0, 1, like Italian, right? And so this is the added thing here. But it was more convenient for me to use this variant of my for loop because this is like making it more cumbersome in the sense that I have to write the entire name of the list again and again because I is the index, I is the number, right? Here I is the element itself, right? So that's the fundamental difference between for I in restaurants. So I is the element itself. For I in range, I is just a number. So you have to utilize that number to utilize the index. All right, excellent question, I would say. That's a common like confusion. Eliana, your question is, when do we use range? Like in the homeworks and labs, sometimes you subtract 1 from the length of the list. Yes, yes. Again, that's a good question. So there is no right, like when we use it depends on the problem, of course. But if you're using something like this, let's say, I don't know what's a good example. Let's say you have a list. Let me just make up something. Okay, let's assume I don't even have a good like. Anyways, I have this list L, and I'm saying there are some elements here, right? And maybe my code is asking me to go over and like compare this and this, and then this and this, or something like. In every iteration, I have to access 2 elements and do something with them, like some comparison or maybe some addition. I don't know, something like that, right? So what will happen is I will, of course, do like for I in L, right? That's the first thing that I'll do. Or for I in range len of L, either one is fine. But because you are asking in that sense, so I'll write for I in range len of L. The other, like what's happening here is that like when I go and say for I in range len of L, I'm going to pick index 0 and then index 1, index 2, and so on, right? And then maybe I need another nested loop inside for j in range len of L, right? I'll write both of them like that. Okay, so here what will happen is I am trying to access I, right? And I'm saying I have to access like, let's say 1 and 2. So this one and this one, right? So when my I is 0, which is like the first element, then my j has to be 2 because I'm doing something with those 2 elements, right? So what I'll do in my inner for loop is that I'm going to say for j in range, and don't begin from 0, begin from 1. So I'll say for range 1 up to len of L, right? So that's what I'll do. So I've like manipulated here. But now what's happening in the outer loop is that this one is also going up to the last element, and this one is also going up to the last element. So there will be a time when we can, so maybe I'm doing like, let me use spider to show you. This is a good question because just bear with me, and I think it'll take some time. So what I'm saying is if you're trying to access 2 elements and for example, first and second, second and third, third and fourth, there is going to be a point where there will be like the last plus 1. And so we cannot do last plus 1, right? And so obviously what do we have to do? We have to like restrict. All right, so here lots of other files open. Yeah, so let's say L equals some 1, 2, and these are all very relevant from the perspective of today's exam. So that's why I'm spending some time on this. So for example, let's say I have to just go and check like whether the first element is like adjacent elements are equal to each other or not, right? I'm making it like very simple, but okay. So what I'm doing is for I in range len of L, and then for j in range len of L. And this should give you an idea of if I just like go and print these i's and j's, you will know what I'm talking about. But regardless, let's say I have to go and compare if this element is equal to this element or not. If it is, then like maybe return a true or print something, I don't know, something like that, right? So I'll begin with the first element here, but I should compare the second element, right? So I have to do something here. So that means that something is going to be like I plus 1, right? And so this is like one way of doing it. Of course, there is another way of uh, doing this as well. So every time, so let's say my I was 0, then this j should be 1. When my I is 1, then this j should be 2. So this here can lead, yeah, so this here can lead to some kind of, I would say, issue, because I'm saying stay I plus 1 and I is going up to the length L, I don't know, something like that. So I'm just like, just for illustration purposes, just like, let's say printing this, right? And let's do this, right? So sometimes I don't want this to go until the end. So I want to miss the last element somehow, right? Maybe I want to add like this element and this element. So in that situation, if I want to miss the last element, I have to like do a subtract here, because I don't want this to like keep going until the last element. Maybe I don't want, what is this, like 6, 7? That's the index, right? So maybe I wasn't clear enough. So because like now we know that this index is printed, that does not exist. Now you will see what I'm talking about. So here, let me just remove this first, right? I plus 1, L sub j. So we are getting 5 and 6, 5 and 5. Um, so we wanted 5 and 6, and like I'm not really getting a good example of where we need that, because sometimes we like high level, let's look at some example, because I really need a good example to illustrate that. Sometimes we just don't need the last one, right? So we just like kind of stop there. Yeah, I think a very good example is that one. I remember it's there in the lecture notes. Remember the one where we were trying to find 3 consecutive double letters? That's where you will see, right? So let me, I don't remember where exactly that one was. 3 consecutive double letters. Remember that problem? I don't know which lecture it is, but that's an excellent example of that. Like we cannot go beyond a certain point, and so that's why we stop there. Maybe we have somewhere here we get into that problem, or maybe I can come back to it at the end of the lecture, because I have to cover some other things as well that are important from the perspective of today's exam. Yeah, thank you, Rochelle. So that's lecture 12. Yeah, lecture 12. That's where we are using that controlling loops. Yeah, that's a good one. So here was an example where we don't go over like all of them, because what was happening here? If I keep going until the end, here I'm trying to access I, right? And then I plus 1, and then also I plus 2, I plus 3, and so on. So this does not exist, right? This I plus 2 does not exist, and so it should throw an error there if I'm not doing this like -5. So that's the fundament. That's what I was trying to somehow illustrate, but it wasn't like really, I didn't have a good problem to kind of illustrate this. So, yeah. Yeah, Thomas, you're saying why is there no 6? Yeah, because that's how we are trying to do. Like I'm always, when there is an I, I'm using an I plus 1. Okay, so going back, this was an excellent example to demonstrate why we use sometimes -5, because for for 3 double letters, there will be some, let me again. Yeah, this is a good one. So let's say I have like something like A, B, and C, right? And so if I go and start like scanning through them, right, I have this if statement. So I'm beginning from S of 0. So I'll have like the first if statement will be S of 0 is going to check whether S of 0 is equal to S of 1, because like 0 plus 1 is 1. So of course, this is fine. And then it's going to check whether S of 2 equals S of 3. So this is 0, 1, 2, 3. All that is fine. And next this is going to check whether S of 4 equals S of 5, right? And so I have S of 4, but I don't have S of 5. So this is exactly what I was trying to make up in that example, but I couldn't. So this is this is going to error out if I don't do this, right? I'm saying like that does not exist. So maybe I'm like trying to stop before. So that's like the fundamental idea of why we do a -1 or a -2. Okay, going back to the examples quickly, because I wanted to cover one more important, this one. So this problem is asking us to work with Yelp data, of course, and assume that you have this code already given to you, and the parse line function will return a list that looks something like this. So although this is assuming that you have the parse line function that's returning some list, but it's good if you review how to parse this and get a list like this, first of all. So that's one. And then how to access this list and do something with it. So for example, this is asking us, okay, for return a list, okay, right, where the last entry in the list is the average rating, modify the for loop above, which is this one, to create a list called high that stores the names of all the restaurants that have an average rating of at least 4. You don't have to print that list. All right. So this problem here is asking you to create a list in addition to whatever you have here. And so that list should be created before, right? And then so basically we have to append some things to that list, right? And that some things will be whatever is in this line, whatever is at the end of the line, essentially, right? So go and check that and keep appending it to my high. That's all this is asking us to do. But why is this important? Because first, reading in the file is important, and then utilizing the data that you're reading from the file and create some other object. So for example, in this case, we're creating another list that's high, right? So quickly going over this won't hurt. And in general, just like know that like how parsing happens, right? So for line so this is like in general, I'm saying open whatever like file.txt. Remember how we do that. And so then we can do line equals line dot strip dot split by the separator. Let's say that the separator was like a pipe delimiter. If it's space, then just like not have anything there. And once you have that, so in this problem, they're saying we already have all of this in here, right? All we need is like a list that should be created somewhere here. So maybe I'll have like, let's say high equals an empty list, right? And then all of this is fine because we are asked to modify this, right? So all I need is like, I don't need to print anything here. Instead, I'll have an if statement that checks this P line. And this P line is nothing but this thing here, right? So if P line at position, let me see, 0, 1, 2, 3, 4, 5. So this is at position 5. If this is greater than equal to 4, then just like go and append to high, right? So high dot append and append whatever we need to append, which is like the name of the restaurant. So this is going to be P underscore line at position 0. All right, so the key takeaway is not like that this problem is hard, but how to read in a file, how to get this list of the elements of that file, and then how to use that to create some other object. So it could be a list, that other object would be a list or even a set or a dictionary. Right, so how to create basically a set, a dictionary, or a list using data from a file. All right, so that was the key takeaway from this problem. Let's go move on and see if there are some other problems that I wanted to discuss. A game of chess takes a single string as an argument, returns the combined values. All right, this is, I would say, relevant in the sense that it's using like a string function. But I think most of you are familiar already with like the dot count function. So essentially, this is like a string coming in and we are counting these elements in that string, and then maybe reporting a score based on like whatever values each of these has, right? So I don't think this was something that was there in exam one as well. Okay, given a file, this is a, maybe this is a good one. Okay, so you have to sum the elements given in a file, which is again fine. Important is like make sure that you know how to use the open function. So for line in open, the name of the file, and then do a dot split by commas, of course, because these are separated by commas, and then like sum them up, right? So you need like sum of all the columns. So the sum is going to be like sum 0 is going to be separate, sum 1 is going to be separate, and sum 2 is going to be separate, right? Because like when you do a dot split, you would have created a list. Okay. These are, I don't see a lot of confusion. I remember one was a very important problem when we were dealing with lists, and that is a common sort of issue that comes up when we are using lists. Okay, what is the output type? So these are more like related to what the format of the exam used to be earlier, like before we switched to online. Uh, there was this problem that I really wanted to talk about, and I've had that question multiple times, so that's why I'm. Where is that one gone? Okay, so this is good. This one, you're given a list of lists representing an n by n grid, right? So this grid is like a list of lists, and you have to print something like this. And if you remember, like the practice exam, that also had somewhat similar kind of a thing where you have to build this list of lists and then also print it, right? So if you're familiar with how to access this list of lists, then of course you can go ahead and print it, because first there will be a nested for loop, right? Because I'm accessing the list and then I'm accessing the elements. And once I'm inside the elements, I have to like print this, like it's a good practice to print like in the form of a string. Maybe like create a string and like keep printing it with the print formatting. So this also is an important question, but from the perspective of like accessing the elements rather than printing. So if you're comfortable like using the print statement, different parameters of the print statement, I think this is something that's good. That should be, you should be good with that. All right, here, problem number, I think 20 or 21. Yeah, this one. I've had this question multiple times, so I got a lot of questions. So let me. Okay, Caesar, your question is, if a text file has only one line, would you still recommend we use for line an open file name, or we should just like use the readline function? If it has only one line and you know for sure that this type of a problem will always get files with a single line, then only use readline function. Otherwise, it's always recommended, even if the file is empty, that you go and open it, put the content somewhere, maybe create a data structure like a list or a set or a dictionary where you put the contents. Because remember, we are writing code for a more generic sort of input rather than like what example or sample input is provided to you. Thomas, your question is, can you explain how to print in spaced formats such as that grid again? Okay, yeah, I can show you the, like maybe some kind of a high level solution. Let me also go over other questions. How to print in spaced format. Can you go over the while loop? And Harun, your question is, how can we go over the while loops and when to use while, true? Well, that's a logic type question, right? And when to use while true versus when to use while I is greater than a number depends on the problem, right? And depends on the programmer. Like I can code that up in a different way as compared to what you can do. But one like rule of thumb is problems like these. I think we have a, yeah, this one. So whenever you see like write a piece of code that repeatedly asks the user for something, right? So whenever you see that, it's usually like advised to use while true. because while true is more like you have set a flag that will keep running until you explicitly go and give it some stopping criteria. So for example, in this case, it's saying when the user enters stop, then you just like exit the loop. So while true is like an infinite loop, you have to go and break it based on certain condition, which will be true only when somebody enters stop, right? So in this, whenever you see like run the code repeatedly, use while true. You don't have to even like think about anything. But in certain other cases, when uh, there is some situation, there is some condition, right, based off of which you want the loop to run, otherwise you don't want the loop to run, then you will write like while condition and then go inside. Uh, uh, okay, Christoph, your question is uh, yeah, even I'm seeing this issue that like all your messages, like everybody's messages are like here coming to me as privately. So I don't know why, because I would like it to be to appear to everybody so that everybody knows the question. Is a question ever going to require that we use specifically a for loop? No, no, never, I would say. So I never do a restriction on like use of for loop versus a while loop. Yeah, it's up to you. Like restrictions are only like based off of what we have covered in class, essentially. So like sometimes we ask you not to use this because we have not covered it, and so it's more likely that you like copied it from somewhere or like, so that's why we ask you not to. Yeah, I was like coming to this one because I've had a couple of emails asking about this one and like why something works versus the other. And so let me like take it to Spider and like see how we can do this one. So I have like this list, right? And the problem here is asking us to write a function, or maybe it's not even asking us to write a function. It's more like a conceptual question. And why I'm like looking at it is because you might be using this kind of a construct in some of your solutions, and you might get stuck like, why is this thing happening, right? So what they are doing is like there are two solutions and both of them don't work. And I wanted to go over why they don't work, right? So let me just do this. So this is a list. And the first solution here is doing something. Wait. This, yeah. Okay, so let's say the problem was that I have to modify my original list, right? Such that like all whatever value is provided here gets removed. So for example, let's say this run is for like remove this x and remove 4 from x, right? That's what this function is supposed to do essentially. And let's see. So what I'll do is first I'll create x. And if you remember what happens to lists when we pass them in a function, they are this L is the alias for X, right? So I'm making changes to L, and if I'm making changes to L, they will be reflected in X. So I'm covered there if I want to like update my original list, right? And what's happening inside for item in L, that means go and check every element in L, right? And if that element, because that's my item, is equal to 4, which is my val, then go and remove it, right? So seems pretty obvious that this should work fine. And so let's try doing this. All right, so what we wanted to do in this problem was to remove 4 from the list, right? And it has in fact succeeded in removing this 4, right? And in removing this 4, one of them essentially, and one of them is still there. So although I'm trying to do this, what exactly is going wrong, right? This is what we want to know here. And maybe one way to kind of illustrate what's going on is like maybe I can print my X or my L here, right? Because the name here is that. And let's see what's going on. All right. So this should kind of ring a bell whenever you're using this kind of a construct here, like uh, a dot remove or a dot pop, because like anybody has like any guesses of like what's happening here? Okay, a few questions. Let me first like answer them, right? Eliana. Eliana, you're saying you have to change. I have to change the settings. Okay. All right, I'll try doing that like in the next lecture maybe. check the settings and then do that. I don't want to like do anything as of now. Charlie, your question is, do you recommend to write the code in words first? Well, it's totally up to you, whatever you're comfortable in, because like we have this time constraint. And if you feel a question is like really overwhelming, writing in words first and then converting to Python wouldn't hurt. Like if you are just like spending 5. Okay, so question to answer to that question, a lot of you are like replying now. So Caesar, excellent. So this is what I was about to say, and you can like tell by printing this list here, the length of the like my list, which is L, right, is changing. So every time we are removing an element, the length has changed, and I'm saying for item in L, but this item is already picking those like one element at a time, right? So when the length has changed, and when I reach at this point, right, my length has changed, like it has reduced by 1 already, right? But the track of the items that my item is picking up, like maybe is at this position. And so like when one of the elements was removed, the length of the list was removed, the index was going on. And so there happens like a point here, as you can tell from here, like the first 4 is removed, right? The length of my list has changed. So eventually, like when we reach somewhere here, one of the 4 gets removed, but then the list length changes, and so it directly jumps to the next index, right? And so that like when 4 and 4 come like next to each other, one of them gets missed because after deleting, I already reduced the length, and then my item index is already moving forward. So the issue here is not just like why, like what's happening to the list. The issue here is like a larger one. When you're working with some list, be careful when you're using functions like remove and .pop, because remember they're changing my original list and I'm looping over my original list, right? So maybe one way could have like one way out, of course, in such situations is to use a while loop, right? Maybe have like in the while, and that goes back to the question that was asked, like which loop to use when. In situations like these, I think it's recommended to use a while loop, or even in a for loop. What we could have done here, that instead of like actually picking the items from L, I could have taken the length of this list and did like a for range in length, but then that would give me an out of index error, right? Because my length is changing. So in either case, a while loop is the recommended one here, because I can simply say go and count like the 4s, right? And as long as the count of these 4s or these vals are greater than 0, that means there is some remaining there. And so keep looping over that and keep removing that val. That's one way out, because in the while loop, it's only going to test that condition, right? So maybe what I'm saying here is, instead of doing this, I could have done like while L dot count. And remember, a while loop like is infinite until that condition is met. So it'll go and scan the list again and again. So while L dot count val is strictly greater than 0, right? And then just L dot remove val, right? So here it's going to work fine, because here I'm testing this condition, and so it's not really iterating over the loop, iterating over the list. And that's why the other solution that's given here, or the other example, will also not work. Why? Because again, I'm doing an L dot pop, and then I'm also looping over the range length of L. So this length of L would have changed, and this won't help, right? Yeah, I think most of you answered this question correctly. Yeah, some elements get skipped over because I'm changing the list. So what is the bottom line here? The bottom line is, when looping over a list, make sure when you're using like functions like .remove, .pop, on that very list, you can like get a wrong solution, right? So that's why I wanted to go over this one. Right. Let me quickly check if there is something that's remaining. Then we can go to the exam, back exam. Right. What is the output type problems were mostly because when we were not online, then we used to give these type of problems, but not anymore. Rochelle, your question is, can you go over what print without any input does in a loop? If I am understanding this correctly, you're saying like if a print statement is there in a loop, it would just like introduce a single line, right? So without any input. I'm not 100% sure, Rochelle, if I'm getting your question correctly, but maybe you mean like if I have something like for I in range, some number, and then I have like a print. Is that what you're saying? So print in general will anyways like print a line, because like by default, even if I don't provide anything, it has like that \n, right? Oh, it was on the back exam. Yeah, so maybe when we need an extra line, right? And usually we use that in like nested loops, I would say, for J in like range, I don't know, 5. And let's say I'm printing, sorry, let's say it's 5, make it shorter, 5. So you have to like think of what exactly this is doing, because like, let's say I have something here. So I'm printing again, I comma J. And like every time I print this I comma j, I need an extra line added, right? So that's what this print will do, right? It's mostly used when you're using like some kind of formatting. So for example, I wanted like when every pair is printed, I want an extra line here, right? Or maybe I wanted extra lines like every time a pair is printed. So then I'll have the print statement there. And so you'll see like these extra lines get added, right? And this goes back to the actual structure of the print statement, which is that it has a \n there all the time, right? So with that \n, an extra line will always be added. So that was, yeah. I saw other questions. Kiran, your question is, does this apply to adding values? Okay, so if you're saying dot append, right? Think about it. If you're using dot append on the same list, so that's what I'm saying. If the list is changing and you're looping over that list, and if it is somehow, I would say, affecting your solution, then yes, right? Sometimes it does not affect your solution when you're doing a dot append. So maybe no, but like if you're doing a dot append and looping over the same list on which you're doing dot append, then maybe yes, right? It depends on like what exactly you're trying to solve. Caesar, your question is, would you say this exam is harder than the first exam? The first exam was easier by the standards of CS1. If like people who have mentored it, people who have TA'd it, people who taught it before felt that. And that's why we had a higher average of like around 80, which was good. I'm not saying it was bad. But this one, exam 2, is going to be similar in terms of like, if you call it hard, or like in terms of like how difficult it is, it's going to be similar to what we had in the fall, I would say. So if, like you have seen the back exam, it's going to be like similar. Exam 1 was definitely easier than the standards of CS1. So that's why we had a higher average. Uh, Weena, you're saying, are there going to be 2 questions? No, there are 3 questions. There are 3 questions. Just like, so I didn't want to like deviate from what we had in the previous semester, because I already gave you the back exam. So it is 3 problems, just like exam 2 from fall 2020. It's the same. All right, so let's go to the back exam itself, because sometimes we can clarify a lot of doubts here. And I know that here, like this is the first problem is more around like reading in from a file, like the higher level idea, reading in from a file, creating a list of lists, and then doing something with that list of lists, right? And you're going to find like somewhat a similar sort of structured problem on the exam. And additionally in exam 2, because we had 3 exams last semester, right? So on exam 2, we didn't cover dictionaries. So there is no example here that covers dictionaries, although we are covering a small part of that, in the sense that it's just like know how to create a dictionary and know how to access elements. That's it. But still they are there, and this wasn't there in the back exam. So yeah, I mean, the general idea stays the same. Know how to read files from like a txt file. So this is what this one is asking us to do. So this is a sample file where you have like users essentially, and like every line has users, like 2 users, and this is telling us like the connection in a social network. And what we want to do in part A is to use this and create like a function that reads in this file and also takes in some user ID, right? And then once we have that, what we have to do is like we have to figure out that user ID is connected to other people. So what all other people is that user ID is connected with? For example, user 9 is connected with 1, 2, 3, 5. So if you go back and see, yes, user 9 is connected with 1 and with 2, with 3 and with 5, right? So 1, 9 is also connected with 1. Yeah, 9 is also connected with 1. All right. So this should like give you an idea of that we need some kind of a data structure to hold this information. And of course, it's already like evident in the problem itself that you need to write a function that returns a list. And so that makes our life easier in the sense that what I'm going to do high level in this problem is, of course, write a function, right, and take the user ID, and based on the user ID, maybe I'm going to create a list. Whenever that user ID is found, like put the other character in that list, right? This is exactly what I'm doing. And yeah, so that's like high level. And for if you're feeling overwhelmed by like reading the problem, it takes like spend 5 minutes just like trying to understand the problem and maybe like writing the pseudocode. That won't hurt. Like 5 minutes won't hurt because then you'll have a very good idea of like how to write the code. And most likely you will like reach close enough, right? So my recommendation is like take 2 to 3 minutes, maybe 5 minutes max to understand the problem. So for example, in this case, what I'll do is like for like read, so I in open whatever file is there, right? So once I have that, of course, I'm going to do a dot split. So let's say I equals, I don't know, this I dot, maybe I should have done it line, right? Line equals I dot split, split by the separator, of course. Now I know that I have this like list of these elements, right? But what I can do here itself, either I create a list and put like kind of every element in that list, or like go by what the problem is asking me to do. So if I can read the problem again, somehow on the other window, just give me a second. Okay, so once you've written this function, right, it's not giving us any idea of like what exactly do we want to create. So there could be like multiple ways of doing it. Maybe based on like whatever user ID you have, you keep checking that user ID, right? Whether like that user ID, like if that user ID is in this line or not. That is one way. But then remember this dot split is going to convert into a list of strings, isn't it? So if we directly do if user ID in line, right? If I directly go and read into that list, it wouldn't really give me until I convert that one also into a string, right? So one like alternate way could be that like keep getting whatever information I'm getting, right? And keep saving it in some other list and create these sublists and then go in and check those sublists. So either way is fine. I'm not saying that one way is better than the other. So one could be like if user ID inline and then maybe convert this user ID into string type, right? And then check if it is there, then just like maybe keep it in some list that you said L equals empty list, and then maybe do an L dot append, right? So this could be like one way of doing it, just like go and append that user ID and maybe like go over this L later on and convert these user IDs into, I don't know, numbers, because they will again be strings. So either ways is fine. One of the other solutions that was provided on the exam like solution document was that I created this list of lists, right? And then I went over the list of lists and checked for each like sub list whether the element had that user ID or not. So either ways is fine is what I'm saying. Either you do that in this for loop or you go and create another one. That's up to us. So once I have figured a way to find out like which user has what connections, right? Once I have figured that way, I can use this function itself to do the second part, right? So that makes my life easier because the second part is simply saying you did that for one user, now do it for all users. That's all it is saying, right? And usually this is the kind of, I would say, overall structure of the problem. You would, if you see multiple parts, there is something that you would be doing in part one that will be useful in part two. So that's what this is saying, like create a complete network. So I don't think that's like as difficult, except I think every user ID like every sublist corresponds to the user ID. So that's also fine. I would say just like keep appending that like element to a list, and that element is nothing but this list itself, right? So I don't think they're like, once you've figured how to read in the data, right, how to figure out the connections for, let's say, user one or connections for user two, you have a way of like getting connections for every user. So once you have that, just like start putting it in a bigger file, and that's it. That's all we're doing here. All right. Part C is again looping over, and again, I'm like going high level on all of these because yeah, so part C is again looping over what network we'll have, and like additionally we had like this print format. So then again, as long as you're comfortable using print statements, I think you can print this. Essentially what we're doing is, let me again show you, we'll have some list of lists, right? So we'll have like some sublists. So all I'll do is like go over like this list. Let's say this is my final list, right? So for I in L, like have some kind of a print statement that has like print complete network first. So like print whatever we have here, and then go inside that, and then just like have a print I, right? And then this has like colon, and then print the like whatever L of I, right? Because then that's going to be inside that, right? So, or maybe in this case, if I'm saying for I in L, and I has to be the index, right? So here maybe I cannot do I in L. I'll have to do I in range length of L, sorry. Range length of L and not this. Why? Because I have to also print the index, and every index points to the user itself. All right. Okay, the final one was like going again over this like list and checking which connection has the max matching. For example, let's say the user entered 7, right? That's what the example was showing. So if the user entered 7, then we have to go and check like which has like what is the output for 7. Actually, the PDF that I've posted is giving you some like very weird type of problem statement here. But what that's my bad. Actually, what we did was we had updated this problem later on because we figured this is like some, I don't know, convoluted type of a I mean description of the problem. What you were asking them to do was like once you have this information, just like go and print. Somebody is going to say enter like another user and then find the matching connection. So you'll already have them in this list 148. So you are going to print that. Of course, initially I had like this one, and then we wanted to find common with like all the like other users. But now what we are saying is like go and check this user, this 7, and also go and check this 6 and see which one are the common ones. Earlier, like when I wrote this problem, I think and it's in the original form only, but the actual exam was slightly different in the sense that we are asking them to compare only 6 and 7, for example, not the rest of the users, because here it reads as if like I'm asking you to go and check all other users and see which ones are common. But here I'm just like asking, check 6 and 7 and then see which ones are common. That's all we're doing here. All right. So the like an additional solution here could have been to use sets, right? But because this problem, and as I said, we did not allow them to use sets or dictionaries, so it became slightly complex in the sense that you'll have to go and loop over that list of lists and keep checking for every element. But now, because you can use sets, so let's say if such a problem appears, just go and directly use sets, right? Just convert this into a set and convert like this into a set and then just like overlap them. So if there is an intersection, get the intersection, right? All right, so that was problem 1. Again, like focus on this overall structure of the problem, please, because that's going to be important. And like maybe I would say we can expect problems on similar lines. So that's that. The second one is about some computation using list of lists. So the first one was like creating list of lists, right? This one is involving some computation using list of lists. And so here you'll have to, of course, be extra cautious how to access elements in a list of lists, right? So in this problem, it's asking us to generate a triangle of numbers using list of list data structures. Your program should ask the user for the number of rows to be generated. You may assume the user will always enter a positive number, and then begin by creating a list with single sublist containing the value of 1 in it. Okay, so let's quickly jump to what we are supposed to do. And there are some rules here. I can explain to you what the rules are. So let us assume here, like we are asking the user to enter some height. So the user entered height 4. This height corresponds to these sublists in your bigger list. All right, so let me show you. This is fine. Okay, so if the user enters 4, you have to come up with 4 sublists, right? And if the user entered 7, and then you have to come with 7 sublists. But how are these sublists generated? So what you'll do is you'll always begin with this like first and the second one, because the first and the second will also always have 1. And notice every sublist has the first element as 1 and the last element as 1. So obviously when the sublist is of size 1, then you'll have 1. And if it is size 2, then again you'll have 1. So basically this is your initialization. Begin with this initialization, because the problem is itself telling you that regardless of what the person entered, if they entered 1 or 2, you know that this is the sublist, and then these are the sublists, and then you're done. What happens if the user enters something beyond 2, which is like starting from 3? What if they entered 3, right? So in that case, what you have to do is, like, let's say they entered 3, where did this 2 come from? So this 2 comes from like summing up this 1 and 1, right? And if you look at the next sublist, let's say the person entered 4, right? So we need 4 sublists. So I already know how many to append, right, to my list. But then I also need to know the elements in my sublist. And where are these elements coming from? Well, this one comes from 2 plus 1, right? And again, this one comes from 2 plus 1. Okay, so how do we decide this kind of a pattern? Well, like it's already described in the description that every sublist, so this is the first sublist, will have first 1 element, second sublist will have 2, third will have 3, fourth will have 4. So there's a pattern there, right? And then like every element is also like in some form a pattern, because like next, let's say we will have the 5th sublist, right? So the 5th sublist will have like 5 elements. And where will the 5th element come from? Well, the 5th element is going to come from summing up again like certain elements. And then there was an example that's provided, very nice. So this is what you need to print eventually. But let's not focus too much on print, because print doesn't have as many points as generating the exact sublist, right? So let's see how we can approach this problem and how we can do it. So there are 2 things happening. First thing, generating the number of sublist. The second is updating the elements in every sublist, right? 2 things together. And so that's why we'll have like of course, a nested loop. And let me maybe right here. Okay, so I like to write it down, because of course I've provided the solution, but it's always better to kind of go over the algorithm itself, right? So what I'm doing in the like very first thing is like always have the list, the final list created, which is like final, this is going to be my final list, right? And always have the like appended with that 1. Right? So maybe like have a final something like this, because the person is going to always enter 1 or more, right? Now, let's say the user entered h, so that's like my user input, and that's an integer, of course, so convert it to an integer, right? And then as long as my integer, like when it is greater than 1, then I need to do some things, right? When it is greater than 1, then only I need more sublists, right? And then only I need some things to be done to those sublists. Okay, so then that's why here I've selected the while loop, right? Because why? Why am I selecting the while loop? I don't know how many times I'll have to run this. It totally depends on the user input. So when such a situation comes in, when you don't know how many times your loop should be executed, it's always better to use the while loop and not the for loop, because for loop is like a counted loop, right? We know how many times it will be executed. So here I don't know how many times, so I'll just use a while loop. So while h is strictly greater than 1, go here. Let's say h was 2, right? And so the easiest way to do like deal with that is I'll just like go and do a final dot append and just like append 1 and 1. I don't even have to do anything because this is like that one off corner case and get done with it, right? Okay, so once I've done that, I need now another loop for accessing the sublists and adding the elements there or updating the elements there. So here I know that I can specify how many times this loop needs to run. How do I know that? Well, I know that like somebody entered h that is greater than 2, let's say they entered 3. Then I know that this like should be executed some number of times so that I can update the elements in there, right? And so now I can use a for loop in this case. So I'm using for I in range, and that range I is the index essentially. So I want to start from like I want to start generating rows, right? That's the first thing. And then the other thing is to update the elements, and that will not be possible just by one for loop. So I need one loop for updating the sublist, right? Because I need another list here, right? In this final, I need another sublist because like maybe the person entered h equals 3. So that's the first loop. And then the second loop is going to be that I need to update the elements in that sublist that I just added. Okay, so for the outer one, I'm saying for I in range 3. Why am I using 3? Because this code is only for that part when h is 3 or more, right? Go h plus 1. So this all we know why we're doing this. Now, this is up to you. How would you like to add another row to your final? It could be many ways. But important thing here is that I want to append it as a last row, right? So append like some ways like takes care of that, right? Also, in addition to that, I need one, like some element. So let's say the user entered 3. So I already need like 1 and something here and 1 here, right? And that something will of course come from summing up elements from the previous list maybe, right? So one way of doing it is that I create this like row. I know that this is a new row, essentially a new sublist, right? So maybe a new sublist, that's what I mean here. And so this is like the new row that needs to be added to my final. So I'm adding to my final by saying this is my last row. And why I'm saving it in a variable, because I need that variable. I need the elements of that variable, right? So I will extract that from my final, which was the last row. Why? Because like my last row had that 1 and 1 that is going to give me the sum of those elements that I will add in my new list, right? Okay, and new sub, have the ones there already. Append 1. All right, so this was about creating sublist. All I'm left with is to jump into my new row, which I'm just like creating and I haven't appended it yet, right? Just jump into that and start appending the elements of my last row, which was like 1 and 1. And but in the next iteration, it could be 1, 3, 1. Right? So there will be another for loop, but I'm not like going into the details of that one. But now you understand what we've done here. I have picked up my last row, which was 1 and 1 in this case, and then I've created this like empty sort of like sublist that has only ones in it, right? So I'm just like adding 1, 1 to it because it was an empty list. I've just added 1, 1. Once I've added the other elements here, the other element is what? Like 1 plus 1, right? So in this case, it is going to be 2, right? So I'm going to add that. And then once I come out of this for loop, then I'm going to add the next one. Why? Because the structure is like 1 and then something and then 1. So that order has to be maintained, right? So this is like the overall structure, but like breaking it down into smaller parts, like how did we break it down into smaller parts? We said, all right, there could be corner cases that somebody entered only 1 or somebody entered only 2. Then like maybe I'm done here. But then maybe somebody entered 3, then what we have to do? Well, we have to do 2 things, create a sublist, right? And then add elements to it. So first we figured how to create that sublist because the sublist has some size, right? And then we figured that we need another for loop to add the elements. All right, so I think I saw a lot of questions coming up. Let's take that first. Okay, I totally lost. Thomas, you're saying, can you explain how to print in spaced format, such as the grid in the end? Yes, yes, of course, of course. I can explain that. And I'm taking other questions as well. Let's look at like what grid you're talking about. So let's say I have generated this. Where is it gone? The solutions. Yeah, this is like the out, not the solution, but the required outcome, right? And I want to print like this thing in this format, let's say, right? So what I'll do is I'll pick every element and then I want to print it in this format. And so first of all, it has to have some spaces, and then every new sublist should be printed in the next line. So this is like not that hard to kind of figure out how to print. For example, in this case, what I'll do is I'll go over this list. Let's say this list is L. Let's say the name of the list is L. So I'll say for I in L. So I is going to pick up these things, right? But I have to print these elements separately, right? So I'll say for J in I, right? Because J is going to be these elements. And then here comes the print statement. Now, how should I print these I's and J's? Well, the way these I's and J's are printed is that I don't really need to print I because I is corresponding to the sublist. So I just need to print K. But then this K, sorry, not K, this is J. But this J has like, is going to be this and this, right? So if I don't do something here, then this will be printed something like this 1 1 1 1 2 1, right? So I have to like not do like that. And so what I'll do is go and print J, which is, let's say, element 1, right? And then separate these maybe by some space if needed. I don't think even that's needed. The important point here is that we need this end equals space. Why? Because like by default the print statement has end equals backslash n equals backslash n, which means every time, let's say I'm printing this line, right? So the way it will be printed is like 1 and then 2 and then 1. So I have to stop it from doing that, right? So the way I can do that is like print j, which is like 1, and then say ended by a space. So it's going to end by a space, and then print another j, which is 2, and then ended by a space, and then print another one, that's 1. So that's why they will be printed in a single line. Right, another question was, Kiran, you're saying, can you explain range 3 to h plus 1 again? Yes, h means like the number of lines we need here, right? And okay, so here h was decided to be, what's happening? Okay, so h was decided to be like these lines here, right? And the bigger list had the sublist in which like it was known that if the sublist is of size 1, which is like the first line here, it will always have elements 1. If the sublist is of size 2, it will always have like 2 ones. And so these were the corner cases which we already took care of before like using the for loop. So that's why we began the for loop from this third line. That's why it was 3 up to h plus 1, because you know why h plus 1, right? The range function will not take h plus 1, it will stop at h. But the point was, like when it becomes 3, then only we need to add things and do things. There's nothing as long as this is like size 1 or size 2. So that's why we began with size 3. All right. So then, okay. So the question here is, where are we updating the while loop? Oh, okay. Okay. No, that's a good question. So if we go back and see now, I think I forgot to update that. We don't even need a loop there, right? So maybe we can have like an if, because you're right. How will we update that h? We already have like the for loop that's updating my h. But I don't think we even need a while there. You can even just like have if h greater than 1, then do this like final dot, because what's going to happen, that's a good point. Yeah, now I'm thinking I don't even need a while loop. Why did I have a while loop? Right? So all I have to do is like create this like sublist, begin with this initialization, and then check if my h is greater than 1, then just like have 2 of them. Because if this was a while, then I will have these extra size 2 sublists added, right? So have like, sorry, not this. have like this one appended. So it will look something like this. And I think that should be fine. We don't need a while. And so there is no need to update H because I have the inner for loop that updates my H automatically. Well, that's a good point actually. Renji, your question is, yes, Caesar, I think that was that's a good point because the value of H wasn't changing. So we don't even need it. Now I'm thinking because if I have this while here and I'm doing something to H, then this like size 2 lists will again and again be added to my final list, which we don't want, right? So that's a good point. From Renji, your question is, still don't understand how to make 1 2 1 2 1 3 1. Okay, so the inner for loop will do that. So I think we are out of time. Otherwise, you can come to my office hours and I can explain that to you. So in the solution itself, it's there where you can sum the elements up. I think we are out of time, but if you still have any confusion or questions, please join my office hours from 12 to 1:30 today. I'll be there. So yeah, I'll just end this session because we are already over time. So thank you.